Hello, everyone. Hello. Oh, thank you, everyone, for being here. Today, this session is about building autonomous FinOps agents for cost optimization. And I just want to say it's a great time to be in the industry. We were in most of you, I'm sure, were in the keynote, and the pace of innovation is staggering. Tokens, agents, AI, it's a great time to be here. I am Alfonso Hernandez. I'm a product manager in Google Cloud, and I lead the cost optimization experiences within the Google Cloud Console. And joining me today is David.
Hi, everyone. I'm David Dinh. I'm a FinOps consultant, FinOps specialist, optimization specialist with our professional service team. I'm actually considered like a field engineer working with our customers. My role is to help customers build solutions that accelerates their business outcomes. So a lot of times I'm working shoulder to shoulder with them, designing solutions, writing code, whatever it is to help them implement that solution. I've got a team of engineers behind myself as well when I work with customers. But so overall, we're working with them shoulder to shoulder to build solutions that help them achieve their outcome.
So David and I, we were brainstorming about what to do for this technical session. We wanted to build an agent from scratch. And unfortunately, in this room, we cannot have that dialogue, that interaction, but we will be very happy to meet you at the Google booth, and we can answer questions. We can go more in depth into the demos we have. And basically, what we decided to do after brainstorming and playing together with Gemini Enterprise, and different components was to do a simple workflow. We took cost optimization for Compute Engine and build an agent that can help you take that analysis, optimization, and action all the way through that agentic workflow. So this is what we're going to be showcasing today. And basically, what we want for you to get out of this session is understand the shift. So we are hearing from customers. Both David and I work with customers day in and day out. And they tell us that they are tired of just pulling information, going to dashboards, reading data. They want to see how AI can help them move faster and move away from that dashboard into action in a way that is not possible just by pulling data. We will go through the basics. David will show us how you can use Gemini models, the Gemini Enterprise solution, to build that workflow that end-to-end can help with the cost optimization. But we will be focusing on business outcomes. As I said, we just looked at one sliver. This is a framework. We are taking GCE, or Compute Engine, as a reference model, but you can take that and extend it, extrapolate to do whatever you want. And finally, we will be putting all of that together, and we'll see it in action. David will walk us through how to set Gemini, how to set the agent, how to deploy it, how to use it, and then we'll see the agent take action. So what is the challenge? What are we trying to solve with this agent? So as I mentioned, David and I work with customers, and our daily job is to work with all of you to understand what problems you are solving, how are you solving them, what tools you are using, and identify the breakpoints and the friction, and then build to remove that. So when we talked about with customers around cost optimization, the three patterns emerge, and they are always the same. There's data overload. Cloud environments are massive. You have so many resources. We are talking about increasing scopes, tokens, and there's organic growth. That cloud keeps growing, and you need to find that needle in the haystack. What is the best opportunity for you? What will give you the biggest bang for your buck? Because you don't have unlimited time. You don't have unlimited resources, human resources, so you have to find that biggest opportunity. But that's just part of the problem. Once you identify that opportunity, you have a massive fleet of idle disks that you can remove. You need to start analyzing and identifying what is the implications. What implications would you have by deleting those disks? If you have an idle machine, was it idle for a reason? If If you are right-sizing a VM, you need to look to see if there are commitments associated with that. What happens if you change that machine shape? Are you getting out of your commitment? And actually, that cost will not reduce. It will actually increase. And a lot of customers get to that point, and they get to action paralysis. And a lot of those savings get there. They are laying around, and nothing is happening. And then, if you overcome those two challenges, then it comes the third, context switching. There are different teams, FinOps, finance, and engineering. And we know cost optimization is not a one-person's job. It's a team sport. And you need to work with engineering, with DevOps, to make sure that that very simple change, that change in Terraform, that deletion of that disk, that perhaps it's an idle IP that hasn't been attached. There's no way to pay for that. There's no reason to pay for that. But just making that change requires engineering to prioritize that work and then make that change. So how can we help? And we know, let's be real, in terms of finding that needle in the haystack, in GCP, that's pretty much a solved problem. We have FinOps Hub. We have the utilization insights. You can see those recommendations. You can see the resources. You see in the waste map how much money you are spending in those idle resources, in those over-provisioned resources. We tell you the metrics. We tell you if those resources have any commitments that you need to be thinking about. And we give you the recommendation on how to delete the resources. But what's the limitation? The limitation is all of you. You have other things to do. You have finite time to do cost optimization, and you need to be going to that dashboard. That's how it works today. But the next level is having AI-driven productivity, where AI agents can do the heavy lifting. They can do that optimization autonomously by analyzing, identifying the fix, and doing that optimization in real time. So what is the agent, and what can it do? So I want you to think about this agent, the FinOps agent that will be showing up, as another part of your team. This is an extension of your team that can help you do 4 things. We just set the agent to do 4 things. It can observe, so it will be continuously monitoring your cloud environments and your billing data, your performance data to understand what can be optimized. Then it will analyze. It identifies over-provisioned resources and any gaps in code coverage. And then it will think. It will strategize. It will calculate what is the most effective cost fixes while it still protects the performance of your resources. And finally, it executes. It safely applies the changes based on what you approve. The agent will have a human in the loop, so you're always in control. So that's what the agent can do, but how does it do that? Basically, we have 3 main components of the agent. First is the brain. We are using Gemini models in Gemini Enterprise to look and process complex billing data, complex logging and monitoring data, and make logical decisions. Then, what's a brain without data? We need to fit it data, and we have secure data pipelines with data connectors that safely read data from cloud billing, from BigQuery, from different systems, following the IAM permissions and making sure that data is accessed the way you want it. And finally, there's the Action Center. We have built an automated workflow that actually can go ahead and execute those changes in your environments. So we talked about 2 key things. The first one is about the strategy and thinking, the brains of the operation. And the other part that I want to focus on is the execution. So for thinking, how do we make sure that the agent is actually providing you the value you want? We do this by using a data-driven strategy. We feed customers multidimensional data, and we do not allow the agent to guess. It needs to rely on the data. It needs to look at metrics and give you and propose action based on real data. Second, it will synthesize historical CPU and metrics and CPU and memory metrics for the last 4 weeks. And of course, this is a framework. You can change it to longer time periods if you want. And then the system will cross-reference all the performance with the pricing data, with your commitments, and it will recommend the changes for you to approve. Always with the complete business picture, from the cost side all the way to the performance side. That's for the reasoning part. But then what about the action part? What about the execution? We built guardrails. So we told the agent that it can always execute by itself things where there's zero downtime. If there are things like expanding a disk, that doesn't require the VM to be shut down. It doesn't have any impact to the system, so it can go ahead with things like that. For other activities where the VM or the computer will need to go through major changes, we tell the agent, you always have to take a snapshot. There has to be a backup. And then, finally, we have a human in the loop. For any large structural changes like shutting down a VM or making a cut purchase, it will provide the reasoning, it will provide the recommendation, but the human is in the loop, and the human, you, can say whether or not the agent can go and execute the change. So with that, I'll pass it to David to talk about the solution architecture.
Great. Thank you, Alfonso. Thanks for going through that. So we'll dive a little deeper into like how does this all work and how do we design this, right? Gemini Enterprise provides you the model access layer where you have access to the model and the UI to interact with that agent. Agent platform is the orchestration layer, right? So this is where you go out and deploy and manage your agents at scale. Then we connect it to the MCP servers that connects you with your resources, your data, such as like BigQuery, cloud monitoring, and Compute Engine, right? Now we go look at, hey, how do we do this from beginning to end, step by step, right? There's basically 5 stages to this, right? One is we enable the data sources. We connect our data sources, we enable it, right? This could be your billing data, this could be other sources of data that you have. Then we build the agent, right? We build the agent using the Google Agent Development Kit and an IDE. That IDE could be whatever you want to use. I typically use Visual Studio. I'll provide instructions, code into that's used to build the agent, and I then connect it. Step 3 is connecting the agents to the MCP servers and tool sets. You can use the native tools that are available within the MCP server, or you can also add additional tool sets, because sometimes the MCP server doesn't have all the tools that you need. You might need to create your own tools. And then step 4, you deploy that. Once you have that agent built and you have it configured, you're going to deploy this to Agent Engine, right? And then when you want to test the agent, you're going to interact with it in Gemini Enterprise, where you'll be able to test the agent, test the logic, make sure it's providing you the accurate responses that you're looking for and not hallucinating. If it hallucinates, you're going to go back to your code, refine your instructions, refine the tool sets, redeploy, test again, and iterate, right? You'll continue to do this process until you get the right results consistently, and that the information that's providing you is factual, that you can rely upon. Then there's like, hey, I need to ground, as Alfonso mentioned earlier, we need to ground the data to make the agent provide you with accurate responses, right? So the way we do that is we look at the data sources that it needs. So for like, when we're right-sizing a compute instance, we need the billing data to tell us, how much the instance is using, what is the cost for that instance. We look at utilization metrics, right? Because we need to know performance. What is the CPU? What is the memory? What is the disk IOPS that machine is using, so that we can the agent can analyze that data and make an intelligent decision on whether that machine can be optimized.
Hey, David, I have a question there. So in this agent, you only have BigQuery data sources, as I can see. What if I have data in a different system? Is it easy to extend? How does that work?
Absolutely, that's a great question, right? So if you have data sitting, maybe as in a document, maybe as a PDF, maybe as an Excel spreadsheet, right? You can connect those data sources to your agent so that agent can use that as its grounding. So that way, it can look at all of your data and provide that context that it needs. When you're asking it to make a certain recommendation, it can take in those data sources so that it can do that analysis and come up with the right answer for you. In addition to that, we're looking at the recommendations export to BigQuery, right? So today, you're exporting your recommendations to BigQuery. That recommendations engine looks at certain amounts of data. So like, for example, to make an idle recommendation, is looking at 14 days of data. When it looks at a right-sizing opportunity, is looking only at 8 days worth of data. And what we hear from customers a lot is, hey, I need more data. I can't make the optimization actionable on just 8 days worth of data. I need a lot more of that. I need to be able to look back more days of data, which is maybe 30 days, 60 days, 90 days, 100 days, more than that, right? So be able to like customize that look back period and supply more data makes that activity actionable for your engineers. Right? And then the other thing we connect it to is the pricing data within BigQuery, right? When you export your pricing data, you have access, the agent has access to your contracted pricing, your custom price, not just list price, but also your SKU level pricing that you have contracted with Google. And so we use that to ground the data. Then the other thing is about, when we're creating guardrails for the agent, we have to create custom rules, right? And so we created this config Python file that has these parameters or guardrails that you set, right? The look back period, maybe you want, instead of 6 weeks, maybe you only need 30 days, right? In our example, we're using 4 weeks of look back period. There's also thresholds for what you defined as a right-sizing opportunity or an idle resource, right? So for us, in this example, right, we're saying, hey, anything that's 5%, less than 5% utilized is considered CPU idle. Or if the memory is less than 15% utilized, we're considering that memory idle. And then there's like operating headroom, right? So we want to make sure that the performance of the system will have enough burst. So we're leaving the headroom around 70 to 80%. So you have a 20 to 30% buffer in case you need to burst and utilize those extra resources, right? So that's how it makes this. These are the rules that we define, or guardrails. So how it makes its decision on providing you that optimization opportunity. Then, like, how does this all work within the agent's brain, right? How does this all work in terms of like how does it do this logic thinking? How does it analyze this data? So the first thing we do is provide some context, right? We give it your project ID, we give it your billing data. We give it access to your resources so that it sees those resources, understands whether or not they're running or stopped, what is the configuration of those instances. It does all this analysis, and then it comes up with a real-time recommendation on what you should do. And then before it even takes an action, it's going to ask you for permission to do something, right? We don't want the agents arbitrarily making a change or going rogue. So we want to introduce a human in the loop, so that way you guys are in control of what that agent is doing, and you guys provide the approvals before it actually makes a change within the organization. So the step-by-step reasoning is real. So what we did for how it does this reasoning is we look at different types of performance metrics when we're looking at compute optimizations, right? We're looking at CPU utilization, we're looking at memory usage over time, we're looking at disk performance, the IOPS on the reads, the writes. And the way that we're able to capture these metrics is we install the ops agent onto the actual VMs. Without the ops agent, your VMs are going to pull metrics from the hypervisor as opposed to the actual VM itself. So we need the ops agent on these specific VMs to be able to pull the memory metrics and the disk. And then of course, like I mentioned before, the look-back period is 28 days. We're only looking at 4 weeks of data. And then for the workflows to automate the right sizing, right? Typically, you got to take the snapshots because we want to make sure that the machine's being backed up. We want to stop the instance before we change the machine type, and then we want to restart that instance back up again. And if you make a mistake, no problem, right? We can roll back. There's also some additional guardrails, right? So when we're expanding a disk, that's okay, right? We can do that on the fly, no problems. The problem is if there's a recommendation to shrink a disk, there's manual work that has to be done, right? You have to like take the machine down, copy the data, bring up a new disk. There's a lot of data validation that has to happen. You've got to do a lot of testing. So that's a manual process. So we set some guardrails to say, hey, if you're going to recommend shrinking a disk, we don't want you to do that. We do want the recommendation, but we don't want you to take any action. So I'll go through a live demo here in a second, where we're actually going to show you, one, how we built it, how we coded it, how we deployed it, and then we're going to test the agent in real time with some prompts.
So David, before we go there, you mentioned we have Gemini Enterprise, we have the Gemini models. How are you connecting, and we have safe data connectors. Are they MCP servers? Are you going through APIs? Is that something you're going to show?
Yes, absolutely. So when we connect to the model, we actually codified this into our agent. We told it what model to use, and then we also told it what APIs to use, what data sources to use, where they sit. So that way it has all this context. We don't have to provide it. It knows, so like for example, we connected into the BigQuery MCP server, and we told it, hey, this is where my data sits in this table. What it does, it goes through and scans that entire table and understands the schema. So I don't need to tell it, hey, what table, what field, what column. It doesn't need to know any of that stuff. I just need to ask a question, and it will, in the back end, run a SQL query based upon the question that I asked, based upon the context that it has about that table. It already knows my entire table. So in the GCP billing data, you'll notice that a lot of the fields are nested. And a lot of times when you're running a query, you got to unnest those fields. Well, the agent already knows how to do all of that stuff. It knows the entire schema. It knows how it's structured. So that way you don't have to tell it where it sits. Even if it's in a nested field, it knows in the back end that it needs to unnest it and run those queries. So you don't have to do any of that stuff. If you're not I myself am not a SQL person, so I don't write a lot of SQL code. I use my agents to do it, so it simplifies this process. So in our live demo that I'm going to show here in a few seconds here, we're going to go through various different types of prompts, like, hey, what are my recommendations? How much can I save? What's the right sizing process? And those kinds of things. So let's go. So the first step here is connecting your data. So here's an example where I've got access to my data. This is my BigQuery environment, my demo environment. I've got my billing exports. I've got my pricing exports. I've got my recommendations export in BigQuery. This is the context that I provided to the agent. The next stage is how do I build this using my ADK and IDE. Let's roll the video. All right, so this is my IDE. We're using Visual Studio. I've got all of my instructions in code. And basically, this is where I told the agent what model to use and my instructions for the agent, these guardrails, right? Then I have also a config file that has what you saw earlier is basically my guardrails, the rule sets that I've configured. And that's basically what the agent uses to make its decision. All of the reasoning logic is built into the instructions. Let's go to the next slide. Sorry, let's go back one. It's not advancing. Let's go back. Yes. OK, so step 3 is connecting my MCP servers, right, and the custom tools. Let's go ahead and play this video. So here, I've got my MCP servers, which are for BigQuery and Compute Engine. They're highlighted here. I just inserted my code for that. And then I've got some custom tools that I've written because my MCP servers doesn't have all the tools I need. I have some tools for like right-sizing disk. I have some tools for running the monitoring metrics that I need, right? The performance data, how to aggregate that data and analyze it. These are some tool sets that I've got configured and is written in code.
So David, for right-sizing, you said you're using an API, the public-facing APIs?
Yes, these are public-facing APIs that you can use. So like the Recommender API, the Compute Engine API to do all of your compute instances. So like you can call the API to do things like stop the instance, start the instance. You can pull metadata about all your instances. You can list all your instances. So that's how we're fetching all of this data. The agent's fetching this data in the back end.
So just summarizing, we have public-facing APIs. We have MCP servers. So MCP for BigQuery. What else are we using in MCPs?
So we're using an MCP server for Compute Engine, right? Compute Engine, it has all these native tools built into it so that we don't have to call the API. But there's other places where we need to call the API for additional information. Like
what? Can you give us an example there?
So one of the things we're doing is calling the Recommender API. So I know that you're already exporting your recommendations. Why would I call a recommendations API? Well, the recommendations engine exports your recommendations on a daily basis. There may be other recommendations in real time that hasn't been updated yet that the agent doesn't know about because he's looking at a table that only gets updated once a day. I need to see real-time information. So now I've got to query the recommendations API to get real-time information because there may be other recommendations from the engine that the agent doesn't see. So I want to make sure that the agent receives that information and provides that additional context so that it can take all these other inputs to make its decision so that when it provides you an optimization recommendation, it's already looked at all this information that it analyzed so that it provides you something that's very factual.
Thank you.
OK. Let's go to step 4. Let's go ahead and play. So now that I've got my agent running, and now I've got this coded, I've tested it, it should work, but now I'm going to deploy this agent to the runtime. So let's go ahead and play the video. So I have a deployment. Let's go ahead and play the video.
Yep.
There you go. The step 4. So I've got this deployment script that deploys the agent. This process usually takes about 5 to 10 minutes, but with the magic of AI, it only takes a few seconds. So as you see here, I've already started the deployment process, and within a few seconds, it's going to come back and tell you successful. It deployed this agent, right? Now that the agent's been registered into Agent Engine platform, I then copy that URL to my agent, and then I replace that URL because I've already been tested. This is an updated version, so I'm going to replace that reasoning engine with that URL. I'm going to click Save, and then now I've got this agent that I can actually, now my agent is loaded. I can interact with it through Gemini Enterprise. So let's go down to the next video. So now I'm in Gemini Enterprise. Now I can interact with my agent, right? So I'm going to load up the agent. My agent's called the FinOps X demo agent. And I'm going to ask it some questions. The first question I'm going to ask is, what are my recommendations? But before I even ask that question, I'm going to have to do a split screen because I'm going to show you what my instances are on the back end. So when it makes the changes, you're going to see this in real time, right? You're going to see the agent taking action, and you'll be able to see these instances changing right before your eyes. So again, I'm going to ask it, what are my recommendations? And the agent's going to come back with a response. This should only take about a few seconds, maybe a second or two. All right, so it came back with some recommendations. It says I need to purchase a bunch of CUDs, right? 1 year, 3 years, vCPU, memory. It's calculated the savings. It calculated even my break-even points, right? Then it gave me a list of all my instances that I've got running on the right side. And it asked me, hey, do you want me to analyze the performance data for these VMs? I'm like, yes, go do that. So now it came back with some recommendations for all of my instances. And you notice here it says, hey, go ahead and terminate your instances. I'm like, wait a second here. I need these instances, right? Even though these instances are not being used, they're idle, it technically can be terminated. But I only have these 4 instances running in my environment, so I don't want these to be shut down. So I now provide some additional context for the agent, tell them, hey, I need these instances. I can't turn them down. Give me some better recommendations. So now it's going to come back, okay, well, here's a recommendation. Since you can't turn off these machines, here are the updated recommendations. It's saying, hey, resize these instances from to an N4 standard 2 or an N2 standard 2 for app 1. So then it gives me a summary of each VM, why it made those decisions, what it's recommending, and why it's making those recommendations, right, for each of the VMs. Then I'm asking, well, if I'm going to right-size these instances, I should be able to save money, right? Let's ask you, well, how much can I save by doing these right-sizing activities? So now it's going to give me a savings for each of these machines as it's making changes. You can see here that it's for over-provision VM1, it's recommending to change the machine to an N4 standard 2, and this is the savings. Same thing for app 1. Right? We can see the disk that it's recommending as well as the savings per month. And it's going to do this for each of the VMs, and it's also going to provide me a summary of all of my other recommendations. So as you can see here, it's saying even for that the small VM, right? It's saying, hey, you're actually going to spend more money because you're going to change the disk type, and that performance is needed and warranted. So the $4 that you're going to pay extra is worth it, right? And then I'm going to ask you, like, hey, what are my steps to right-size my instances? Because I want to make sure the agent knows what the process is, right? Because we gave it some guardrails, we gave it some instructions, but I want to make sure that it understands what the steps are. So it says, hey, I'm going to create a snapshot, stop the instance, set the machine type, and then restart the instance, right? And then it also gave me if it's doing a shrink of the disk size, it says GCP doesn't support that, right? Because we want you to it requires manual intervention, and we don't want the agent to do that. So the next step is, hey, I think this looks good. I'm going to go ahead and ask it to go make some changes now. So I'm like, help me right-size app-1, right? App-1 right now is an N2 standard 4. It's going to resize this instance. And then it says, so here it says, hey, I'm going to resize the instance. Do you want me to also resize the disk? I'm like, no, don't touch the disk. Just touch the machine. I don't want the disk to be touched. So now it's reiterating that. Now it's asking me for approval. Hey, is now saying, hey, we're going to change that machine, and we're not going to change this. Do you want me to proceed? I'm like, yes, go ahead and make this change. Now it's going to create the snapshot for the disks, for all the disks that are attached to that VM. It's going to power down that system. And so I'm going to click refresh here, and you'll see the VM actually refreshing, and the machine is actually spinning down. This process takes about 2 minutes for a machine to shut down. So we're going to wait for this process. While this process is continuing, we're going to validate that the snapshots are actually being created. So now I'm going to go down to my snapshot, and I'm going to be able to scroll down and see that the actual snapshots is actually being created in the process, and it's still spinning. There you go. You see that that snapshot is being created. Now I'm going to switch back to my VM instance. By now, the machine is probably on its way to being shut down, and the agent came back and says, yep, the machine's being already terminated. I've already changed the machine shape to an N2 standard 2. I'm going to refresh my screen here where my instances are being, where you see the spin on the instance. And you should see that instance now has been changed to an N2 standard 2. And the machine is actually spinning back up. And so once the machine spins back up completely, the agent's going to come back and confirm that that machine has been restarted and it has been successfully changed to an N2 standard 2. So we'll do a little refresh here, and you'll see that the machine is actually running now. Yep, the machine's running. The agent came back and said, yep, your machine's been changed. But what if I made a mistake? I want to roll back. So I'm like, hey, I made a mistake. Let's just roll back the changes for app-1. So now it's going to go through that same process, but it knows that it doesn't need to do another snapshot because it already did that, and it's just doing roll back the changes. So it's just going to terminate the instance, make the change, and restart it again. Again, this process takes about 2 minutes or so. It's already stopped the instance. It's made the change back to an N2 standard 4, its original configuration. It's going to spin back, it's going to start up that instance. This will only take about a second or two to start the instance, and then it's going to confirm that that instance has been started, or confirm that those changes are successful. Yep. Again, this process only takes about a second or two. It's going through the motions. It's actually already done. I'm going to hit the refresh button here, and the machine will refresh. There you go. It's already started, and the machine's changed back to its original condition, and the agent's already verified that the instance is running, and those changes were successful. Let's go to the next slide. Or next slide. Yep. So in conclusion, right, we built this autonomous agent to do a simple use case, which was right-sizing an instance, looking at various different data points. Right, the agent is able to address these, overruns in terms of like the over-provisioned resources, the idle resources, right? Provide you actionable insights, right? It's able to like codify these fixes, right? Without doing any kind of Terraform or anything, it's gonna identify the fix, code it, and then do it, right? So you get improved efficiency by just having the agents act on your behalf, which frees up your time to go get coffee or get your morning breakfast. So what I'll leave with you today is stop doing the, where you're building dashboards or reports. That's the old way of doing things. We're well beyond that, right? This is the new era where you want to use agentic workflows to optimize your environment, to automate your manual workflows so that you're not relying on a manual dashboard or a manual report that doesn't provide you all of the insights that you need, where you're still going to have to go out and fetch more data to determine whether or not something is actionable, right? So with that, go out and build agents. If you need help building agents, please come by our booth. We'll talk to you about how we built this. If you want a more in-depth demo, we can do that as well. If you want deep dives on the code, how we develop the code, we can do that as well. And I think we also, if you were in our session from yesterday, we actually open sourced some of our MVP code, and we can share that with you after the session. We can just drop by our booth. We'll give you the QR code where you can actually access our open source code.
Yeah, and I just want to add, thank you for joining our session. And I think it seems very daunting, agentic and tokens, but I was brainstorming with David on how to build this. He went away for 1 day. He brought a prototype working. We just refined it, and within a couple of days, we had this working. So We have a lot of tools. There's a lot of resources. Gemini Enterprise is a fantastic tool for you to explore. So if you want to see this in our computer, we can show it. Unfortunately, here we couldn't have a computer to building this alongside, but we have it, and we can show it in the booth. So thank you.
Yeah, so the other thing I'll add is that this agent was built 100% with AI, right? I write Python, but I don't do it in my day-to-day job. I'm not a really good coder, so I let AI do this. And so AI was able to build this from end to end within a matter of hours, within a matter of minutes, really. And the only thing that took the longest was the instruction sets, right? Testing it and then refining it, because sometimes it may pull the wrong metric. You have to tell it, hey, make sure you pull this specific metric that I'm looking for. And so those are some things that you have in the guardrails and test those things out. So those are the things that took the longest, but the AI built it from end to end completely, right? And so this is where you can leverage AI to help you, codify or build some of the projects that you guys have. And the IDE that I'm using is, if you guys are, Google has released a product called Anti-Gravity, right? It's a Visual Studio fork that's public accessible. It has built-in AI models like Gemini or Claude or Copilot. You can integrate it with your own model that you want to choose, and it will help you build your code side by side and test it within your IDE. So that's what I use for building these agents out.
Okay.
Yep.
Well, thank you.
Well, yeah, thank you for attending.
Hey everyone, producer Andrew here. Thanks for watching. Check out the rest of our channel for more FinOps content. Like, subscribe, and leave questions and comments for our speakers. We appreciate your support.